Well, welcome to the video on polymorphism. In the previous video, we looked at inheritance concepts, such as in inheriting a child class or parenting from a parent class, and then we looked at different ways to inherit the parent constructor, and we saw the value and advantages of inheritance. In this video, we're going to take a look at polymorphism. Specifically, we're going to take a look at method overriding as the main principle in Python for polymorphism. First thing that you need to do is you need to start and open a new Python file, and we then need to open our code from the previous lesson. Once you have your code from the previous lesson, copy it and then paste it into your new file. Then save your file. And finally, open your driver file. All right, so the first thing that we're going to do now here is a mammal class. Now, in the mammal class, what we're going to be doing is we're going to be adding a new method. We're going to call this method display attributes. In fact, the same name as our display attributes that we have, print all attributes that we have from our previous human class. So inside here, what we want to do is we want to print the 3 attributes that we have in our mammal class. So what I'm going to do is I may as well just copy and paste this one that we've already created and modify it for our mammal class. Now notice here that, again, we can choose between going with the protected attribute, underscore, single underscore, or we could actually use our properties and setters. Now, since we've got these property and setters here, we may as well use them. So I'm just going to be going self.furType. Self.desiredBodyTemp. And self.currentBodyTemp. We've now created a function that has the same name as what we have in the human class. In the imperative paradigm, this would actually throw an error. We are not allowed in the imperative paradigm to call a function with the same name, just like we're not allowed to call a variable with the same name. But in OO with polymorphism, that is one of the 4 pillars, is that we are allowed to do this and basically reduce redundant code. So what we're going to do to show the power of this is now go to our driver and we're going to create 2 new objects. We're going to delete any code here, and we're going to now inherit from polymorphism. Import from the polymorphism file. And so now what we can do is we can create a new mammal. Now you'll notice here that as I'm trying to do this, I can't inherit the mammal for some reason. And the answer is that at the moment, I'm only importing the human class from here. It's as like the mammal class does not exist because I haven't told it to import that code. So therein lies the power of external libraries, is that you can actually specifically only get the classes that you particularly want. And that will save, I guess, the time it takes to load these libraries in. It might only be a fraction of a second, but it may make a difference. But in this case, we want to inherit both the human, or import the human and the mammal class. And so now when I do this, I have absolutely no problem. Okay, so the first thing that we want to do is set the current body temp. So we're going to set that to be 38 degrees, and this will work because of our properties and setters. There is no underscore there. We're just using that the setter method there. And then we're going to set the mammal fur type to be just a default, because look, mammals, they have different fur type, so we'll just say that it could be anything. And then I'm just going to say to the console, we're going to now print the mammal attributes. I'm going to display all those attributes. Name, print all attributes. All right, now let's create a new human. And let's populate it with some attributes. All right, and then we're going to now say we're going to print the human attributes into Python, and then we're going to print all attributes. Now, let's run this. All right, so let's debug and find out what's happening. Okay, so in this case, what's happening is it is expecting a default number in here. So it's expecting the current body temp. So we've actually populated it here. So we can actually just put 38 and let's run this again. Okay, we've got another error. Okay, so the other error that we had was that we didn't remove the self.name. I'll just save that. We've got another error here, line 23. Okay, so it's very similar. We don't have a desired body temp. Let's try that again. So now we finally got it working. What we've just done is polymorphism. We've done what we call method overriding. So you can see here by default, the print all attributes prints three things: fur type, desired body temp, and current body temp. But when we create our child class, we can override what's in the print all attributes and customize it for our own situation or our own class. And you can see that not only does it have current body temp, it also has a bunch of other things as well that are unique to humans. And so that is method overriding. And it's one of the principles of polymorphism. I'd like you to pause the video now and make sure that you firstly create your own print all attributes method and customize it for the mammal class. Then in your driver code, make sure that you import the mammal class. You create two new objects, a new mammal, a new human, and you initialize the current body temp, the desired body temp, and the fur type. Print out the attributes of both the mammal and the human. We're going to continue on showing principles of polymorphism here. And I'm going to create a new method in the mammal, the human class, and then we're going to create a dog class as well. And this new method that we're going to create is just called the communicate method. So by default, a mammal that communicates just makes noise, okay? But a human that communicates talks. If we create a new class, and we'll inherit that class, the mammal class, we can create a attributes and methods. Like for this particular situation, I'm not going to actually populate any attributes. And I'm going to bark. So let's just save that. So I've created my three communicate methods. Let's add a new dog here. Firstly, let's import the dog class. Yep, so make sure we've got to import the dog class first, then we can create a new dog. I might just remove these here, and then I'm going to communicate. So the first one will be the mammal one communicates, then the human communicates, and then the dog communicates too. So let's just run this. Oh, of course, I need a current body temp for the dog. Okay, so you can see here that I've got three things. So when the mammal communicates, we have a make noise, but when the human communicates, it overrides what the communicate method was in the mammal class, and it's unique to it, which is talk. And of course, when the dog communicates, it overrides what's in the mammal class and it barks. So this is another example of method overriding. So what I'd like you to do now, in a moment, is pause the video create three new methods, communicate methods. One in the mammal class, one in the human class, and one in the dog class after you've created the new dog class. Then I need you to add a new dog, make sure that it has a current body temp, and then communicate with the three objects that you've just created. So please pause this video now. So the next thing that we're going to look at is, this is all well and good, but when you start creating multiple objects, it can be hard to keep track of them if you do it like this. Let's just say that you've got a game, for example, and that you've spawned, say, 100 enemies. And that can be concerning if you're using 100 lines of code to spawn the enemies. What you want to do is use a loop, firstly, to spawn the enemies. And secondly, use a data structure, such as a list, to contain all the objects. And then you can pull out the objects when you need them or reference them when you need them. So let's delete all of this code except for the top line in our driver code. We're still going to create three objects and we're still going to make the mammal communicate. But I'm going to show you how it's a little bit more cleaner. So what we can do is we can create a list in Python. So I'm just going to create what we call a mammal list, blank list. Then what we can do is we can append to that list and we can start adding to the mammal list. So we can say, well, the first thing that we want to add is a new mammal that has a current body temp of, I don't know, by default 37 degrees. Sorry, this new mammal has a body temp of 37 degrees. Then the next one that we have is a new human. And then we need to kind of fill out all these attributes again. And then the last one that we've got is a dog that has a current body temp of 35, say. Great, so now we've added three new mammals into our list. And then once they're in the list, we can then loop over them and communicate much easier. So in the previous one, we had 3 lines to communicate, one for the mammal, one for the human, one for the dog. In this one, we're going to have 2 lines using a loop. Now imagine if I had 100 objects, and of course you can populate your list a little bit differently. Maybe if you had a text file, you could import the text file and use a loop to do that, which would be much cleaner, or even use random values. But anyway, so I'm just going to go for each mammal in mammal list, I'm going to use the communicate method. Mammal.communicate. Now this is where the method overriding comes in. So you can see here, we're still making noise, we're still talking, and we're still barking. But this is the beauty thing, right? Because each one has a communicate method. And in our list, we say, well, for each mammal that's in our list, and it's adjusting depending on what object it is. It's saying, well, for a mammal, I'm just going to make noise. But for the human, I'm going to search for the human communicate, which it finds and it changes, which is talking. So you can see the advantages here of method overriding. All right, so I'd like you to pause this video and I'd like you to get this code down that basically allows you to use a list to store all your objects in, and you can then use a loop to communicate. To finish off this polymorphism video, it's worth mentioning about method overloading. Now, method overloading is possible in Python, but it's used a lot in Java and C#. Now, method overloading is this idea of having the same method name, but the way to distinguish them is that you can have different parameters. So with method overriding, it works with inheritance really well. But method overloading in C# and say Java, for example, you can do it in the same class. So for example, you might have a cat class like for example here. And by default, if there are no parameters going into the sound method, it's going to just print out a single meow. But if you put a number in as one of the parameters for the sound method, then it will loop as many times as you put the number in. Now, I know that's not exactly what this code does, but let's hypothetically imagine that that's what it should do. And it would print meow, meow, meow. Let's say if you put 3 as the parameter in. And so method overloading basically changes depending on what parameters you put in. Again, polymorphism at play here. It has many forms, all right? Same method, but many forms. Now, unfortunately, in Python, we have an attempt at method overloading, but it doesn't really do it properly. So you can see here, let's say we've got a calculator class, and we've got an add numbers, a simple add numbers, 2 numbers. Okay, so for example, if we receive 1 number, then it's going to just add that number. But if we receive 2 numbers, then we're going to add those 2 numbers. If we receive 3 numbers, it's going to add those 3 numbers. Now, in Java or C#, we would create 3 different def add methods. One would have 1 parameter, the second one would have 2 parameters, and the third one would have 3 parameters, and it would be altered based on the scenario. However, in Python, we can't do this. So the way we have to approach this is use the default, or I guess none parameters. So we have to receive an A parameter. That's a non-negotiable, but these are optional, basically. And if they get received, then we've got a string of selection statements, basically helping us decide what to do, which is essentially what method overloading does in the background. It kind of works it out for you which method to use. Look, this is really the only way we can do method overloading in Python. So just to recap, what we've done so far is we've created a new display attributes in the mammal class. We then printed out the mammal and the human class, and we saw that the human class overrode the print display all attributes or print all attributes method in the mammal class. We've learned obviously to declare different types of objects now. And we then created a third class, a dog class, where we've created a method in all 3 of them called communicate. Again, show an example of method overriding. Polymorphism at play there. We then finally we looked at the keeping a track of our objects in a list, which is much cleaner when you have lots of objects. And then, finally, that we looked at the concept of method overloading and how it's quite restrictive in Python, but it's used extensively in C# and Java. Well, I hope you've enjoyed this series. If there's anything that you are still struggling to understand, please go back and review the videos. All the best with your object-oriented journey.